On this slide, you will see the three basic types of fractions. You have a proper fraction, an improper fraction, and a mixed fraction. The proper fraction has a smaller number on the top. The 1 is the numerator, the 3 is the denominator, and 1 is less than 3, so it's proper. You can also see it visually, that the green section is one section out of 3. And it's not completely shaded, only part of it is shaded, so again, proper fraction. Improper fraction, you've got more shaded than just 1. You've got 5 on the top row, 5 on the middle row, and 1 more on the third row. So if you counted those boxes, you would have 11. 11, and they're fifths, so it's 11 fifths. If you counted the holes that you have, the top is a hole, the middle is a hole, and a little piece out left over. 2 holes and 1/5 left over, 2 1/5. The mixed fraction, or sometimes called a mixed number, you can see that you've got a whole and a half, so that's 1 1/2. If you wanted to turn that into an improper fraction, you would count the number of pink pieces that you have. You have 3 pink semicircles, so 3 halves, because that's what the size is, they're each a half. Mixed number is a whole number plus a fraction, so 4 1/2, 6 2/9, 8 1/2. An improper fraction is a fraction in which the numerator is greater than or equal to the denominator. 5 is greater than 3, and 7 is equal to 3. This next slide, I'm going to demonstrate how you convert, and this is really very important to know how to do this when you are multiplying fractions or when you're adding and subtracting. You need to know how to convert and go back and forth. So if we have the fraction 4 2/3, which is a mixed number, we're going to say 4 times 3 plus 2, all over your same denominator. If you see a 3 there, it's going to be a 3 here. So 12 plus 2 is 14 thirds. The next one, we have 9 times 4, and we're going to add 1. Your denominator is always and forever going to be the same as in your mixed number of 4. So 9 times 4 is 36, and 1 is 37 fourths. Same thing here. 6 times 8 plus 3. 6 8s are 48, which is 51 eighths. Going the other direction, we're going to divide. This bar here means divided by. So 11 divided by 3, well, that's going to go 3 times. 3 times 3 is 9, 2 left over. It goes 3 times, 2 left over. And your denominator is always and forever going to be the same denominator. 9 divided by 4 is 9 divided by 4. That's going to go twice. It's going to go twice with 1 left over, 4. 12 over 4 is 3. It's simply a whole number, 3. All right, now, try these, write them down, put it on pause, and then let's see how you do. All right, here's a solution. So we have 5 times 4 is 20, plus 1 is 21 fourths. 7 times 3 is 21, 22, 23 thirds. 7 times 2 is 14, plus 5 is 19. And you'll see the denominator always is the same. Same thing here, 16 divided by 5. Well, that's going to go 3 times with 1 left over. It's easy to double check these. 3 times 5 is 15 and 1 is 16. It's almost easier to go from a mixed number to an improper fraction. 8 divided by 3. 8 divided by 3 is going to go 2 times with 2 left over. 2 times with 2 left over. 2 and 2/3. Let's check. 2 times 3 is 6, 7, 8. Yep. 15 divided by 5. Well, that's simply going to be a 3. A nice whole number 3. All right, how'd you do? This workforce product was funded by a grant awarded by the United States Department of Labor's Employment and Training Administration. The product was created by the grantee and does not necessarily reflect the official position of the U.S. Department of Labor. The Department of Labor makes no guarantees, warranties, or assurances of any kind, express or implied, with respect to such information, including any information on linked sites and including, but not limited to accuracy, of the information or its completeness, timeliness, usefulness, adequacy, continued availability, or ownership.